In this lesson, we're going to talk about linear quadratic systems. A linear function and a quadratic function can intersect at a maximum of 2 points, and these points of intersection can be found graphically or algebraically. So let's just think about that for a second. We could have a parabola and a straight line intersecting at 2 points. We could have a parabola and a straight line intersecting at 1 point. We can have a parabola and a straight line intersecting at no points. Same holds true for two parabolas. We could have two parabolas that intersect at 2 points, two parabolas intersecting at 1 point, or two parabolas that never intersect. Okay? So let's do a couple examples here. Determine the point or points of intersection, if any exist, in the following cases. The first one, we've got the parabola and the straight line given. Well, to determine where there's points of intersection, we can set these two equal to each other and solve for x. So 3x squared minus 10x minus 100 equals negative 4x plus 5. This is a quadratic equation because of the exponent of 2 and the equal sign. We add 4x and subtract 5 from both sides. We common factor out the 3. And then we see that two numbers that multiply to negative 35 but add to negative 2 are negative 7 and positive 5. So 3 times x minus 7 times x plus 5 is 0. That means either this factor is 0, which would mean x is 7, or this factor is 0, which would mean x is negative 5. That means there are 2 points of intersection. Now, to get the y-coordinate of those points, we're going to take that x value that we just obtained, and we're going to plug it into either this expression or this expression. Either one is fine because they're equal to each other. So, at x equals 7, I'm going to choose the linear expression because it's a bit easier. Negative 4x plus 5 ends up equaling negative 23. So one of the points of intersection is 7, negative 23. When x is negative 5, negative 4x plus 5 ends up equaling 25. So one of the points of intersection is negative 5, 25. So the 2 points of intersection are 7, negative 23, and negative 5, 25. Okay, what if we have this line and this parabola? Here's our linear function and our quadratic function. We set them equal to each other. Subtract 10x, subtract 5 from both sides. And we see that this factors nicely into 2x plus 5 times 2x plus 5. That equals 0. Well, that means 2x plus 5 equals 0, which means 2x is negative 5, or x is negative 5 over 2. So what we can then do is take this x value of negative 5 over 2, plug it into either this expression or this expression. I'll plug it into this one right here. At x equals negative 5 over 2, 10x plus 5 is 10 times negative 5 over 2 plus 5, which equals negative 20. So what we've got here is a parabola and a straight line that intersect at 1 point. The point negative 5 halves, comma negative 20. In this situation, we've got a quadratic function and a linear function. So what I'm choosing to do here is isolate y and get this into y equals mx plus b form. So we have 3x minus 2y minus 14 equals 0. I subtract 3x and add 14 to both sides. I divide both sides by negative 2. And I get that another equation for this line would be y equals 3 halves x minus 7. Okay, now what I can do is set this expression equal to this expression, which I do right here. I subtract 3 halves x and add 7 to both sides. And what I'm going to do, just because I prefer to work with integers, is multiply all terms, including the 0, by 2. And then I'm going to solve for x using the quadratic formula. So, using the quadratic formula, I get x is 23 plus or minus the square root of negative 2,351 all over 16. But this discriminant is negative. I can't take the square root of a negative number. So when I have a negative discriminant, that means there's no solutions, so there are no points of intersection. Now, we could have, if we chose, instead of doing it this way, we could have merely taken this expression right here, 4x squared minus 10x plus 38, and plugged it in for y. And then re-express this whole long equation. It would have been 3x minus 2 times 4x squared minus 10x plus 38 minus 14 equals 0. And then we could have created a quadratic equation with one side equals 0, used the quadratic formula, and we would have gotten this